Okay, this video will be the second video on how to solve quadratic equations. More specifically, this video goes over a process called completing the square as well as the quadratic formula. Alright, before we go over completing the square, we need to answer the question, what is a perfect square? A perfect square, I'm going to give you some examples, would be like x squared plus 8x plus 16, because that can be rewritten as x plus 4 times x plus 4 if you factor it, which can be rewritten as x plus 4 squared. Another example would be x squared minus 12x plus 36, because this can be rewritten as x minus 6 times x minus 6, which gives us x minus 6 squared. Alright, now I'm going to show you the process of completing the square by doing an example, because I think that will be the easiest way for you to understand. Right. For instance, if I tell you to solve x squared minus 2x minus 8 equals 0 by completing the square, the first thing you would need to do is make sure you have your x terms on one side and your constants on the other. Since we have a minus 8 on the left hand side with our x terms, we would need to add 8 to both sides. So that would give us x squared minus 2x equals 8. Now, I left a space between the minus 2x and the equal sign for a reason. Because pretty much what we're about to do is we're about to create one of these perfect squares that we discussed on the previous slide. The way we do that is we take the number in front of our x term, which in this case is minus 2. We cut it in half or divide by 2. That gives us negative 1 in this case. Then we take the number we get after we divide it in half and square it, and that gives us positive 1. So that number we get after we square it, we add it to both sides. Now, if you factor the quadratic on the left-hand side, we need the factors of 1 that add to give us 2. And that would just be 1 and 1. And 8 plus 1 on the right-hand side gives you 9. Now, since the second sign is addition on the quadratic, that means both those factors have the same sign. Since the first sign is minus, that means they're both negative. Now, one thing that might be interesting for you to note is, see this number here, the minus 1? That's the same number we get whenever we divide this first number in front of x, the minus 2, whenever we cut it in half. So, you know, since we have the same thing divided by itself, we can just rewrite this x minus 1 times x minus 1 as x minus 1 squared equals 9. So, if you want to know a shortcut, after you take this first number, the number in front of x originally, and you cut it in half, you can just write your perfect square here, x, and then whatever number you get here, put it in there, and then square it. So x minus 1 squared is equal to 9. From here, you take the square root of both sides. That tells you that x minus 1 is equal to positive 3, and x minus 1 gives you negative 3. If you solve for x, you get 4 and negative 2. Alright, if I tell you to solve x squared minus x minus 30 equals 0 by completing the square. First, write out your equation, then add 30 to both sides. And make sure to leave your space because now you have to complete your perfect square. Alright, Since there's just a negative sign in front of x, that's like having a negative 1. So you take that negative 1 and divide it by 2, and you get negative 1/2. You need to square the negative 1/2, and then you get positive 1/4, because a negative times a negative gives you a positive. 1 squared is 1, and the 2 squared on the bottom would give you 4, so that's how we get the positive 1/4. So on the left hand side we have x squared minus x plus 1/4, and on the right hand side we have 30 plus 1/4. Alright, now on the left hand side we have the x squared minus x plus 1/4. Since the number we got after we divided by 2 was negative 1/2, we can create our perfect square, x minus 1/2 squared. Because if you were to expand x minus 1/2 squared, you would get x squared minus x plus 1/4. And if you doubt me, or if you don't think that's true, you can either FOIL it yourself or you can ask me in class. But anyway, on to the right hand side. 30 plus 1/4. Here you go, I'm going to work out the math for you. 30 can be rewritten as 120 over 4. Just because we want to get into the same denominator as the 1/4. 120 over 4 plus 1/4. 120, now we can add, since they have the same denominator, we can add the numerators. So 120 plus 1 gives you 121 over 4. Now if we want to take the square root of both sides, now that would give us x minus 1/2 equals square root of 121 is 11, square root of 4 is 2, so positive 11/2 and negative 11/2. So now if we add 1/2 on the left equation, we would have 12 over 2, which means x is 6. And on the right equation, the x minus 1/2 equals negative 11/2. If we add 1/2, we get negative 10/2, which would be negative 5. Alright, here's another example. Solve x squared plus 10x minus 2 equals 0 by completing the square. Again, our first step, as always, get the x's on one side and the constants on the other. So we would need to add 2 to both sides. And that would give us x squared plus 10x is equal to 2. Now we complete our perfect square on the left hand side. We need to take the number in front of x, which is 10, divide it by 2. That gives us 5. And then if we square 5, we get 25. So if we add 25 to both sides, well, we know since we got 5 after we divided, the left hand side would eventually simplify to x plus 5 squared. And in case you still have issues seeing that, we need the factors of 25 to add to give us 10 on this quadratic up here. The factors of 25 to add to give us 10 are 5 and 5, so this would factor down to x plus 5 times x plus 5. And that's how we can rewrite it as just x plus 5 squared. I just did the shortcut that I showed you previously. And on the right hand side, 2 plus 25 is 27. So now, if we square root both sides, we get, before we simplify it, before we solve, let's see if we can simplify square root of 27. We know 27 factors down to 3 times 9. Square root of 9 is 3, so that simplifies to 3, then times the square root of 3. So x plus 5 equals positive or negative 3 square root of 3. Now if we solve for x by subtracting 5, we would have minus 5, or negative 5 plus or minus 3 square roots of 3. Alright, here's an example. Solve 2x squared plus 12x minus 5 is equal to 0 by completing the square. Alright, now we can start by doing it the same. add 5 to both sides. So that would give us 2x squared plus 12x is equal to 5. Now the thing that's different about this problem is that we have the term in front of x squared. Before we can do completing the square, I'd recommend just divide everything by 2 so we can get the term in front of x squared. So we can get the number in front of x squared equal to 1. That's what I'm trying to say. Because if we divide by 2, those cancel out. So we just have x squared. Then 12 divided by 2 gives us 6x equals then 5 halves on the right hand side. Now 6 divided by 2 is 3. 3 squared gives you 9, so we add 9 to both sides. So now we can factor down the left hand side to just x plus 3 squared, which is the number we got after we divide by 2. And now 5 halves plus 9. Alright, 9 is just 18 over 2. So 5 plus 18 is 23 over 2. Square root both sides. You have x plus 3 is equal to, we could do, let me do another side note. You can rewrite the square root of 23 over 2 as the square root of 23 over square root of 2. Now, we normally don't like having square roots on the bottom, so we'd multiply by the square root of 2 on both the numerator and denominator. That would tell us that on the denominator we have square root of 2 times square root of 2, which is square root of 4, which is just 2. Now on the numerator we have square root of 3 times square root of 2, which is square root of 46. Now since we're solving an equation, it would be positive or negative. So now we have x plus 3 is equal to positive or negative square root of 46 over 2. So we could now solve for x by subtracting 3 from both sides. That's supposed to be a 3 right there. Those cancel out, so you're left with x equals minus 3 plus or minus square root of 46 over 2. That should be 46, not 6. Now, I'm happy with this answer. Your book goes further, has square root of 6 plus square root of 2 plus or minus square root of 46 over 2. And it even goes so far as to combine those two. X equals, since they have the same denominator, combine it into a single fraction. X is equal to square root of 6 plus or minus, or x equals negative 6 plus or minus square root of 46 all over 2. Now, you may have seen this in previous algebra classes, the general equation for the quadratic. Solve ax squared plus bx plus c equals 0, because that's the general equation for any quadratic, by completing the square. Alright, you'd start by doing it the exact same. So if you subtract c from both sides, you would have ax squared plus bx is equal to negative c. Now, you need to get the number in front of x squared, the coefficient of x squared, equal to 1. To do that, you have to divide by whatever the number is in front of x squared. But what you do to one thing, you have to do to everything. So if you divide everything by a, you would have just x squared plus b over a times x equals negative c over a. Now, you need to divide the number in front of x by 2. Another way of dividing by 2 is multiplying by 1/2, which might be easier in this case since we technically have a fraction. Now, if we multiply by 1/2 or divide by 2, because that means the same thing, we have b over 2a. And we have to square this. So that would give us b squared over 2 squared, which is 4, and then a squared. So we can add b squared over 4a squared and then we can write our perfect square. This left-hand side can be rewritten, since they're both addition signs, our perfect square would be a plus. The number we got after we multiplied by 1/2 was b over 2a squared equals, now this minus c over a plus b squared over 4a squared. I would say, to get them the same denominator, multiply it by 4a on both the numerator and denominator. Because since the first fraction, the minus c over a, does not have a 4, and only has one a instead of an a squared, you need to multiply it by 4 and by a again. So that would give us, let's put the positive thing in front, so it would be b squared over 4a squared minus 4 times a times c. Right here you have 4 times a times c, or minus 4ac, all over 4a squared. Now, if we take the square root of both sides, we would have x plus b over 2a is equal to, since we took the square root and we're solving an equation, it would be plus or minus. Now, on the denominator, square root of 4 is 2, square root of a squared is a, so plus or minus 2a. And we can just leave the top part as square root plus or minus square root of b squared minus 4ac. Now, since we're adding b over 2a to x, if we subtract it from both sides, those would cancel out, so we're just left with x on the left-hand side. Now, since we have the same denominator here and here, we can just combine the numerators, the minus b and the square root, into one fraction, so it would be minus b plus or minus the square root of b squared minus 4a, that should be a c right there, all over 2a. And if you notice right here, the formula we get after completing the square on the general equation, you might remember that as the quadratic formula. Alright, solve x squared plus 5x plus 2 equals 0 by the quadratic formula. Notice our number in front of x squared is 1, so our a is 1. Our number in front of x is 5, so our b is 5. And our constant is positive 2. So we plug those numbers into our quadratic formula. Our negative b are opposite of b. The opposite of positive 5 is negative 5, plus or minus the square root of b squared, so it would be 5 squared, minus 4 times a, which is 1, times c, which is 2, all over 2 times a. X equals negative 5 plus or minus square root of 25, because 5 squared, minus 4 times 1, which is 4, times 2, which is 8, all over 2 times 1, which is 2. So we can simplify this even further. X equals negative 5 plus or minus the square root. 25 minus 8 is 17, all over 2. Now, since 17 I don't think simplifies any further, we can just leave it like this. Alright, solve x squared minus 2x plus 19 equals 0 by the quadratic formula. Alright, so your a is 1, your number in front of x squared is 1, your number in front of x is negative 2, and your constant is 19. So, to simplify this, or to plug it in now, you follow the quadratic formula. X is equal to negative b, or just the opposite of b. So the opposite of negative 2 is positive 2, plus or minus the square root of b squared minus 4 times 1 times 19, no, minus 4 times a times c, all over 2 times a, which is 1. Now we can simplify this. 2 plus or minus square root of negative 2 squared is 4, minus 4 times 1, which is 4, times 19, which is 76. So 4 minus 76 all over 2 times 1, which is 2. Now this can be simplified even further. 2 plus or minus square root of negative 72 all over 2. Now since we have a negative 72, I know y'all like complex numbers, so that's what we're going to end up with here. Now, I'm just going to simplify square root of negative 72 here, and just plug it back into our values of x. Alright, this simplifies to negative 1 times 9, actually, times 36 times 2. Now, square root of negative 1 is I, square root of 36 is 6, so it would be equals 6 times I. The square root of both of those, 6i times the square root of 2. So to plug it back in, we have x equals 2 plus or minus 6 times I times the square root of 2 all over 2. Now, since 2 is divisible by 2, and 6 is also divisible by 2, we can simplify it. Let's see here. 2 divided by 2 is 1, plus or minus, now the 6 divided by 2 is 3, so 1 plus or minus 3 times I times the square root of 2. And those are your values for x. Alright. So if I tell you to solve this equation by the quadratic formula, even though our a is not 1, see, even though it's actually 2, our b is 4, our c is negative 3, respectively, since our number in front of x squared is not 1, even though it's not 1, we can still use the quadratic formula the same way. All we have to do is plug our numbers in, our opposite of b, which would be, in this case, it would end up being negative 4 plus or minus the square root of 4 squared minus 4 times a times c, so that would be 4 times 2 times 3. All over 2a, so 2 times 2. Now it would actually be negative 3. So this would simplify to negative 4 plus or minus the square root. 4 squared is 16, and 4 times 2 is 8 times negative 3 would be negative 24, so 16 minus negative 24 all over 4. Now simplify to negative 4 plus or minus the square root of 40 all over 4. Remember, square root of 40, if you want to factor it down, would be just 4 times 10. Square root of 4 is 2, so you're left with 2 times the square root of 10. So this can be rewritten as negative 4 plus or minus 2 square roots of 10 all over 4. Now if you notice, this number, and this number are all divisible by 2. So if we reduce that to 2, reduce that to 2, reduce that to 1, divide everything by 2, we would have as our final answer -2 instead of -4 plus or minus 2, instead of 2 squared root of 10, it'd just be square root of 10 all over 2. Now the last thing this video will go over is the part of the quadratic formula we call the discriminant. The discriminant is given by b squared minus 4ac, the part underneath the radical. That's what we call the discriminant. And of course, once again, I ran out of room to write, but I'm sure you can spell because it's written at the top too. Now, there are 3 things I want to discuss on this slide, or 3 points. When the discriminant is positive, that means you have 2 real roots, meaning your quadratic crosses the x-axis twice. Now the second thing is when our discriminant equals 0. That's whenever we have 1 real root, meaning our quadratic just touches the x-axis. The third instance is when our discriminant is less than 0. That means we have 2 complex roots, meaning our roots are going to have an I in them. For example, if I tell you to determine the nature of the roots of 5x squared plus 2x plus 7, meaning I want to know if the roots are going to be real or complex, and if they're real, if it's going to be 1 or 2 real roots. So, if we notice, our a is 5, our b is 2, and our c is 7. So we can look at the discriminant to determine whether the roots are going to be real or complex, determine if they're going to have an I in them or not. So it'd be b squared minus 4ac, or 2 squared minus 4 times 5 times 7. So that would be 4 minus 4 times 5, which is 20, times 7 is 140. Which means our discriminant is negative 136, which is less than 0, obviously. That means we would have 2 complex roots. Alright, suppose I tell you to determine the nature of the roots of 2x squared minus 6x equals negative 1. Alright, in order to be able to use the discriminant, we actually need everything on the same side instead of opposite sides. So that'd be 2x squared minus 6x, and we would need to add 1 to both sides, so that'd be plus 1 gives you 0. So our a is 2, our b is, in this case, negative 6, because the number in front of x has a minus sign, and then our constant is positive 1. So if we do b squared, which would be negative 6 squared, minus 4 times a, which is 2, times c, which is 1. Negative 6 squared, since the negative is in parentheses, it ends up becoming positive, so it'd be 36 minus 4 times 2 is 8, times 1 is 8. So it'd be 28, which is greater than 0. Since it's greater than 0, we have 2 real roots.